Chapter 1.8 Security. The Kubernetes documentation provides guidance on how to run workloads securely and maintain the security of a Kubernetes cluster. It emphasizes the importance of following best practices for cloud-native information security, drawing on advice from the CNCF. For a deeper understanding of securing your cluster and applications, it is recommended to read Cloud-Native Security and Kubernetes. This resource explores the broader context of security in cloud-native environments. Kubernetes Security Mechanisms. Kubernetes offers various security features and controls to protect the cluster and its resources. One key aspect of security is controlling access to the Kubernetes API by configuring TLS for data encryption in transit and for data stored within the control plane. Secrets API can be used to protect confidential configuration values, while enforcing pod security standards ensures proper isolation of pods and containers. Network policies can control network traffic between pods and the outside network. Kubernetes also provides audit logging to document user activities, API usage, and control plane actions. Additionally, encryption at rest can be enabled for data stored within the Kubernetes control plane to enhance overall security. Deploying security controls from the wider ecosystem can further protect pods, containers, and the images they run. Cloud provider security. This text mentions that the Kubernetes project authors are not responsible for third-party vendors, products, or projects listed on the page. If running a Kubernetes cluster on personal hardware or a different cloud provider, it is recommended to consult documentation for security best practices. Links to popular cloud provider security documentation are provided for reference. Before adding a vendor, product, or project to the list, it is advised to read the content guide for submission guidelines. Kubernetes offers various ways to define security policies, including network policy and validating admission policy. Additionally, users can utilize policy implementations from the larger Kubernetes ecosystem. The platform supports extension mechanisms that allow ecosystem projects to implement their own policy controls on various aspects such as source code review, container image approval, API access controls, and networking. For further information on policy mechanisms and how they can be implemented in Kubernetes, users are encouraged to read up on policies.